Welcome to This Explainer. Today, we're diving straight into the intense, completely hidden mechanics of home heating and cooling, and we're using Beech Grove, Indiana as our ultimate stress test. We all just sort of expect our homes to magically stay at a perfect 72 degrees year-round, right? We're totally oblivious to the mechanical warfare happening right now in our basements and attics. So today, we're pulling back the curtain to see what it actually takes to keep these machines alive. So let's kick things off with a massive question. Why do these systems secretly fail right when we need them the most? Well, your air conditioner and furnace aren't just casually blowing air around. They are locked in a continuous, brutal battle against environmental extremes. And if we don't understand the invisible strain our systems are under, we're essentially just sitting around waiting for an incredibly expensive midnight breakdown. And that brings us to the invisible enemy, 80%. In places like Beech Grove, summer humidity regularly pushes past an oppressive 80%, which forces air conditioners to run constantly. They aren't just cooling the air down, they are literally wringing gallons of water out of your home's atmosphere. If they fail to keep up, that moisture breeds mold right inside your ductwork. Okay, here's our roadmap for today's explainer. 1. The climate challenge. 2. The anatomy of HVAC failures. 3. The science of proper sizing. 4. Solving the efficiency puzzle. And finally, 5. The professional standard. Let's jump right into part 1, the Beech Grove Climate Challenge. When we break down the seasons, there's a really stark contrast between the dual threats your system faces. On one hand, you've got this mold-breeding summer moisture causing constant runtime. But then, on the other hand, brutal winter temperatures drop below freezing for weeks at a time. This inflicts an immense amount of free-flow stress on heat pumps and furnaces. It's basically a pendulum of extremes that gives your equipment absolutely zero time to rest. But get this, the attack isn't just coming from the sky, it's actually coming from the ground, shifting beneath you. Beech Grove is notorious for clay-heavy soil, so as that soil expands and contracts, your foundation settles. This movement literally pulls your home's ductwork apart at the seams, creating massive air leaks. Suddenly, you're paying to pump beautifully conditioned air directly into the dirt of your crawl space. Unbelievable, right? Which brings us to part 2, anatomy of HVAC failures. Let's define a major killer of these machines, short cycling. This happens when an HVAC unit turns on and off far too quickly, failing to actually maintain the temperature in your home. Worse than that, it's the mechanical equivalent of flooring your car's gas pedal and then immediately slamming on the brakes over and over again. It destroys motors and compressors incredibly fast. And beyond short cycling, older homes frequently suffer from a compounding list of mechanical casualties. We're talking expensive refrigerant leaks, especially if you're still using that outdated R22 fluid. We also see failing electronic ignition sensors, those torn duct seams we talked about, miscalibrated thermostats running off false readings, and even clogged condensate drains that can trigger a total emergency shutdown of your system. So every homeowner is really up against a ticking clock here. Year 0 is your installation, but somewhere between years 5 and 10, those manufacturer parts warranties just vanish. Ultimately, even with flawless maintenance, extreme environments limit a system's lifespan to roughly 15 to 20 years. If your system is in that end-of-life window, constantly repairing it is often just throwing money into a sinking ship. Let's move on to part 3, the science of proper sizing. Now, there is a stark contrast between outdated contractor guesswork and true professional precision. The old way relied on rules of thumb, basically just guesses, that usually resulted in oversized equipment. And an oversized unit cools the house way too fast without actually removing the humidity, leaving you with a cold, clammy home. The professional standard, however, is the ACCA Manual J load calculation. It uses precise math, factoring in your exact climate zone, your insulation levels, even your window area, to perfectly match your home's actual demand. Okay, part 4, solving the efficiency puzzle. So having the right size is only half the battle. You also absolutely need to understand your SEER and AFUE ratings. SEER measures air conditioning efficiency and AFUE measures furnace efficiency. A higher rating does mean a higher upfront price, sure, but it also means drastically lower monthly operating costs. Knowing these numbers tells you exactly how fast an upgraded system is going to pay for itself in energy savings. Now, here is a shockingly simple but totally vital defense against high energy bills. Replacing your filters correctly. Got pets? Allergies? Or is it just the absolute peak of summer? You need a fresh filter every 30 days. Period. A dirty filter literally chokes your system, forcing it to work twice as hard to push air. That accelerates wear and tear and completely drives up your bills. Furthermore, modernizing with a smart thermostat, it isn't just some flashy tech gimmick, it's a serious financial investment. These devices actually learn your schedule and use geofencing to know exactly when you leave the house. By automatically slashing energy waste when you're asleep or at work, these thermostats frequently offset their entire purchase price within just 2 years. And that brings us to our final section, Part 5, the professional standard. When we're dealing with hazardous materials, the stakes are incredibly high. Older systems often contain outdated refrigerants, like that R22 we mentioned earlier, which actively deplete the ozone layer. Handling these chemicals requires strict EPA Section 608 certification. This ensures technicians are legally and safely recovering the refrigerant, which protects both your system's integrity and the global environment. But safety goes way beyond just the chemicals. Bypassing local building codes and skipping permits when replacing equipment is just a terrible idea. In places like Indiana, permits are strictly required to ensure the installation meets mechanical safety codes, especially for the proper venting of deadly combustion gases like carbon monoxide. Skipping this step, it can leave you with a dangerous, completely uninsurable installation. So, a true professional avoids guesswork entirely by moving methodically. Step 1 is a precise diagnosis using actual testing equipment to measure pressures and electrical flow. Step 2, the repair or installation is done strictly to the manufacturer's specifications. And Step 3, comprehensive testing under actual operating conditions, followed by a full walkthrough so you, the homeowner, understand exactly what was done. As we wrap up this explainer, I really want you to take a look at your own home and ask yourself a critical question before the next big heat wave or deep freeze hits. Is your heating mechanical system truly prepared to survive, or are you just one shifted duct or one dirty filter away from a total system collapse? Think about the age of your equipment, the way it's been maintained, and whatever you do, don't wait for a midnight emergency to find out the hard way. Thank you so much for joining me, and keep learning.